of the assignments which are based on trees and graphs, because that implementation will help you in ISC exam. So try to complete all the uh, practicals based on first two units before ISC exam, so that your concepts will be more clear. Okay, the next assignment which we are going to work on is Prim's algorithm, as it is based on the similar line of the Dijkstra's algorithm, which we have seen in the last session. I'll go through the assignment first. Okay, the sixth assignment, it is a business house has several offices in different countries. Okay, this is again related to a real-time application where a business house has several offices, multiple offices in different countries. They want to lease the phone lines to connect them with each other, and phone company charges different rent to connect different pairs of cities. Okay, so they want to do the connection, telephone network connection between the office. Business house wants to connect all its graph where all those offices will be vertices, and there are different possible connections. Okay, so through which we can connect the two offices. Okay, and what we have to do, the business house, they want to connect all its offices with a minimum total cost. That means we have to create the minimum spanning tree where only one line will be implemented out of all possible. Suppose there are 3 4 lines going to a particular office network, then we will be selecting only one line out of that, which will be costing less. Okay, represent using appropriate data structure, that is the first part. So we will be using adjacency matrix, a representation of a graph. Okay, so graph will be the data structure which will be selected to solve this particular problem, and we will use adjacency matrix representation like we did in the Dijkstra's algorithm. Then second part is apply suitable algorithm to find minimum total cost, and here we will be using Prim's algorithm for this. Okay, we will be using, so here we have to use minimum spanning tree algorithm, MST algorithm. So options are Prim's and Kruskal's. Here we will be using Prim's algorithm, and in the next assignment we will implement the Kruskal's algorithm. Okay, is this clear? Is this application clear? So they want to keep the cost of building the telephone network. That cost must be uh, minimum. Okay, at the end. This is the problem which we need to solve using Prim's algorithm. Is it clear? Here, no, shortest path algorithm will not help us. Shortest path is having some different application. In the last application, we have seen that from college, I have to reach to different destinations. Then I can take different paths, and I have to select the shortest path. So for that, Dijkstra's algorithm was useful. Okay, and here we have to find n minus 1 edges which will cost less. Okay, least cost edges we have to find. We'll go through the Prim's algorithm which we have already discussed in the theory, but we'll see what this algorithm tells us. So Prim's algorithm, it maintains the connecting, it goes on updating the single tree by adding one by one edge into it, and the output at every stage is a tree. Okay, and at the end when we have n minus 1 edges in that tree, that is our minimum spanning tree. Okay, so only one tree is modified or enhanced in every iteration. So Prim's algorithm, it is used to build a minimum cost spanning tree T by adding edges to T one at a time. At each stage, add a list cost edge T such that set of selected edges is still a tree. Okay, so in every stage we have a tree. Okay, in which that means it is connected component. Okay, repeat the edge addition step until T contains n minus 1 edges. Okay, so here we have to see that if we start from 0 and then we decide to go to 5, that means this 0 5 edge will be added into MST because it is least cost from 0. Okay, then we have to consider remaining edge from 0 as well as the new edges we can consider from 5, the vertex which we have visited. Okay, so out of 25 and 28 we have to select the next edge, not the other. We cannot move to other vertices to which we cannot reach yet. Okay, so only from visited vertices we have to go to non-visited part. Okay, this is the algorithm. So initially T is empty, then visited vertices set it is 0 because we will start here from 0 vertex. While T contains fewer than n minus 1 edges, let U be with the least cost edge such that U belongs to visited vertices set and V belongs to be visited set. Okay. So initially the minimum spanning tree is empty and U belongs to visited vertices and V does not belong to the visited vertices set. Such edge we have to select. Okay. So that's why it is greedy algorithm, because in every stage we are selecting the least cost edge. Okay, that is the optimal solution at that particular stage. If there is no such edge, break. Otherwise, add V to TV, that is visited vertices. We will mark that node as visited, and add UV to T, that is spanning tree. Okay. So this algorithm we have to implement. We have seen one example of this. We have solved on paper. Then for this particular graph, we solved one example, and here also we used the same variables: cost, matrix, distance, visited from, which we used in the Dijkstra's algorithm. And here we need minimum cost of the spanning tree. Okay, so this one variable will be there, which is added here. So I'll share the complete screen and we'll discuss the example and code simultaneously. Is there any doubt in the algorithm? Shall we move to the execution of it, implementation of it? I hope the algorithm is clear. We have solved some examples for this. Yes, okay. Okay, fine. The similar variables we are going to use, and we will be using here adjacency matrix representation only, and we have seen in the last session how to create the adjacency matrix. Yes, so graph, it is declared as a matrix, and n is the actual number of vertices which is less than 20. Then there is read graph function. In a read graph, we are taking the number of vertices from user and number of edges for every uh, value, ijth value in the graph in matrix. We are initializing it to 0, and for every edge, we will be replacing that particular edge with the actual weight. So we are taking the source, destination, and weight, and we will modify that g of vi to vj and g of vj to vi with that weight. So this is the graph which will get created. Okay, and this will be undirected graph. That's why it is symmetric. Okay, so initially you can start with taking number of vertices, then initializing the adjacency matrix to 0, and then you can take the edges from the user. Number of edges and actual edges will be taken, and with this our adjacency matrix will get created. And then in display function we will be using upper triangular matrix only. We will be displaying the values, non-zero values from only upper triangular matrix. Okay, that's why I equal to 0 to n minus 1 and j equal to I plus 1 to n. Okay, we are not displaying all the values from the matrix. Only non-zero values from upper triangular will be displayed, because the edges will be repeated in the lower triangular matrix. Okay, so we are skipping that. I hope read and display functions are clear. It is exactly same. You can use that as it is from the previous assignment, which is Digicstars assignment. Okay. Then after your adjacency matrix gets created, the next thing is now you have to start traversing. We'll go to the main function and check what we have to do here. Here we are creating a variable g1 for storing the graph. And this spanning is nothing but our output, which is also the object of graph. Because see, every tree is a graph, isn't it? Every tree is a graph. So we can store that minimum spanning tree, the edges which we have selected to be part of minimum spanning tree, we can store them as another graph. That means in a matrix, suppose we put only the edges which are part of the our MST, then that will be our representation. So we can use matrix representation for storing the MST also. Okay, that's why two objects are created here. G1, which is storing our original graph adjacency matrix, and spanning, which is holding only the edges which are part of MST. Okay, so G1 dot read graph, we are taking the input, and total cost is equal to G1 dot prims spanning. So in spanning, the output MST will be there. Okay, we are calling prims function and we are passing the reference to that object, spanning object, where we need that uh, only those edges, MST edges, to be stored. And then we are calling spanning dot print graph. Okay, so only edges from spanning tree will be displayed. Okay, and total cost of the spanning tree is that will also get displayed here, because it is returning that total cost. The prims function is returning the total cost, minimum cost. Okay, so we'll go to the prims algorithm. Is the declaration clear? Why we have used two objects of graph and the graph creation? If it is clear, we will go to the prims algorithm. Okay. Yes, in prims algorithm, again, the first step is to create the cost matrix. From adjacency matrix, we have to create cost matrix where every zero value will be replaced by infinity. Okay, and non-zero will be copied as it is. So creation of cost matrix, that is the first part. Okay, for I equal to 0 to n, j equal to 0 to n. If g of ij is 0, then replace it with infinity. Infinity is declared to be 9999, some greater value. Otherwise, copy the element as it is from the adjacency matrix. Then, at the same time, what we are doing, we are initializing spanning dot g of ij to 0. Okay, you can have separate for loop for this. Don't get confused. We can have separate for loop and we can initialize this spanning dot g of ij in another. Like this. Okay, so we have first created the cost matrix. Secondly, we have created the initialize the spanning tree to 0, every edge to 0 initially. Okay, this is the output which will be modified as we select any edge which is part of MST, then that will get modified here. Okay, that will get added here. Then next thing is distance of 0 is 0 because we are starting from vertex 0, and visited of 0 is marked as 1. Okay, and from 1 onwards, okay, from index 1 onwards, all the elements of distance will get copied from cost of 0I. Okay, from 0th row, the ith element will be copied as it is in the distance array, and from of I will be 0 because we have started from vertex 0. Okay, so for every element, predecessor will be 0 and visited of I is 0. Clear? This initialization of all the variables which we are using here, and minimum cost, it is also initialized to be 0. Okay, minimum cost also is initialized to be 0, which is minimum cost of the spanning tree. And then number of edges are initially n minus 1, and we have to, so this loop is going from n minus 1 to 0. You can go from 0 to n minus 1 as well, no problem, because in the MST we are searching for n minus 1 edges. Okay, is the initialization of all the variables clear so that we can move ahead? Anything that you did not understand? We have not yet started with actual Prim's algorithm. We are still looking for the initialization only. Okay, and after all these variables are initialized, now start the processing. This while loop is our Prim's algorithm. Okay, while we have not added n minus 1 edges into the MST, what we have to do, we have to first find the minimum distance edge. So this part is similar to our Dijkstra's algorithm. We have to find the minimum distance edge from the current vertex. So minimum distance, it is assumed to be infinity, and we will access the distance array, and we will check whether visited of I is 0 or not. So from only non-visited vertices, we have to find the minimum distance edge. Okay, and that is selected to be the next vertex V, and minimum distance is distance of I. Okay, so next vertex, this is the next vertex V, and minimum distance is obtained at the end of this loop. Okay, from non-visited vertices. Okay, you can relate it here. In this also, what we did, we copied all the elements as it is from distance array, and then we replaced this infinity with 0. Okay, this is 0 because it is self distance, and this will be marked as visited 1. Okay, and predecessor for every node is 0. Okay, and then what we did, we found the minimum distance edge, which is 10. From these non-visited vertices, 10 is the minimum distance edge. Okay, so that will be selected as next. So V is 3, that vertex number is 3, V is 3, and U is equal to from of V, which is 0. U is equal to from of V, that is predecessor of this, which is 0. Okay, so this edge 0, 3 will be added into the MST. Okay, see here. So minimum distance will be found from this loop, and that will be the vertex V, and predecessor of that is stored in U. So U is equal to from of V. Okay, and then we will add this edge UV in our MST. So spanning dot G of UV is equal to distance of V, as well as G of VU is distance of V. So we have copied it at both the places. U to V, V to U, because this is undirected. And minimum cost is equal to previous minimum cost, which was 0, plus cost of UV, which is 10. Okay, so this is the things to add the minimum distance age into MST. Now, the further thing is you have to check in that particular vertex number 3 whether you get the better distance edges, okay, from that vertex to the non-visited vertex. Okay, so you will be replacing that. So that vertex number 3 is marked as visited, and the required number of edges will be reduced by 1. And now this is the effect of adding that edge. So what we will do for non-visited vertices, if we get better distance, that is better edge, cost of IV, if it is less than distance of I, then replace that distance and replace its predecessor also. So what is the difference between Digixtras and this? In Digixtras, we are considering the cost required to come to that particular vertex because it is a path. Okay, we need complete path from source to destination. So we are adding that minimum distance, that is distance required to come to that particular vertex, and the distance from that vertex to the other vertices. Okay, so we were considering that cost here. But in prims, you have to directly compare whatever is the value in the cost matrix. Okay, so here infinity is there for 4 and 5. But from D, we are getting the age with 9 and 5. So we will be directly replacing it. Okay, that is the difference here. Yes, it's done. And finally, we are getting the minimum spanning tree, and we have written that print graph function. So after our this spanning objects G, it will be completely created with n minus 1 edges. You can display that here. Spanning dot print graph will give us actual edges which are part of that graph. Okay, or we can say tree, and the minimum cost which is returned from here, that will be displayed here. Okay, is it clear now? This loop is our Prim's algorithm, finding the minimum distance age. Okay, that UV age, U is from of V. So UV age will be added into the minimum spanning tree, and we will modify the cost of that MST. We will mark that vertex V as visited, and number of edges to be visited is reduced by 1. And we will see the effect of adding that edge, whether we are getting better edges to the non-visited vertices, and that those will be added to the MST. If the edges are already visited and we select from that, that will form a cycle. That's why from non-visited vertices only we are selecting the edge. That means we have not yet reached to that. Okay, that means we can replace the edges. So initially, suppose from here, in order to move to vertex F, initially we have selected, suppose for this 15 edge, but afterwards we get this age 5, which is better than this 15, so that will get replaced. Okay, so in order to reach to F, instead of selecting this age, we have selected this age. Are you getting? So finally the output will be the tree which is not having any cycles, like this. And it is having n minus 1 edges and all n vertices. Is the algorithm clear? If you have any doubt, please ask. I'll execute the program. We'll execute the same program for same graph. 1 minute. But if anything is not clear, you can ask. So it is important that you should have one example solved like this, which you can check, okay, where you have created all these distance from and visited array. Number of vertices here are 6. Number of edges are 8. We will enter the edges 0 to 1, 15, 1 to 2, 12, and 2 to 3, 10, 0 to 3, 10, then 2 to 5, 15, 3 to 5, 5, and 3 to 4, 9, and 4 to 5, 8. So this is our graph, all the edges which are there in the graph, and total cost of the spanning tree is 45. Okay, so these are the edges in the spanning tree because we have displayed spanning object. Okay, spanning dot print graph. So these edges are there in the MST. We will check whether the same is there. 0 to 3, 10. Okay, this is the first edge which was added. 0 to 3, 10. Then 1 to 2, 12. 1 to 2, which is 12. Okay, the predecessor for this is 2. So 1 to 2. Then 2 to 3, 2 to 3, which is 10. Then this one 0 to 3. This is already considered. Okay. 5 to 4, which is 8. And 3 to 5, which is 5. Okay, all these are the edges which are part of our MST. So total cost is 45. If you check here, okay, initially the minimum cost was in the first iteration when we selected this age it was 10. Then it uh, went to 15, then 23, 33, and 45. Okay, which is the final cost. And these are the different ages which are part of it. Is it clear how to interpret these arrays, distance and from arrays for the output? If you have any doubt, please ask. So, when your Dijkstra's algorithm is working, immediately you can go for Prim's algorithm and it will not take more than half an hour. If the concept is clear, if the algorithm is clear, difference is clear, you can immediately implement this algorithm also, Prim's algorithm. Okay.